Hello everyone! Today we're going to create this volumetric effect in Unity. I hope you're enjoying it. I love it because it gives a really cool effect. And this is basically the exact same thing that Unity released with their VFX graph samples. So let me show you the original scene that Unity provided. You have to get the samples from the Unity GitHub and you will be having AR radar, morphing face and other things. And let me show you the volumetric, and this is the effect that Unity used and showcased it in their forums. And we will be creating this today. However, I won't be making the exact same scene and environment like Unity. Instead, I will be using the original HDRP scene that Unity provided. Now let's get back to the first scene, and I have also included the volumetric fog, and you can see the shades of lights in here. So for now, let's get it started. I will be disabling density volume and deleting the old VFX that I created. And now let's create the VFX. Also, you will be needing the samples. You can get it from the Unity GitHub, because they have some textures that we will be using in our project. So let me delete the old one and create a new VFX graph. Let's see, where is the VFX graph? Yeah, here. And I'll call it volumetric test. Also, let's drag it into this hierarchy and move it to here so that we can see it better. Now let's open it up. Now, before adding anything interesting in here, let's just tweak some of the basic parameters. And for the constant spawn rate, we are going to have lots of particles. So I just set it to 20,000, and for the capacity, we will be having 100,000. Also delete the random velocity and set the lifetime from 3 to 7 seconds, and expand the bounds in here and set the center to 0 and set the size to 40, 40 and 40. And after all, just delete this because we are going to need a lit quad to get the translucency effects and get the volumetrics. Now let's just come here in the initialize particle, and if I get back, you can see that all the particles are at the same position. So we don't want that, so we add a position sphere, and let's expand the sphere and reduce the radius a little bit. And if I go back, you can see the particles are being spawned on the surface of a sphere. And if I go inside this sphere, you can see that it's empty because all of the particles are on the surface. So for this, we are going to change this to volume instead of surface. So let me check that, and now you can see. If I go inside it, you can see that it's filled with particles. Now, we are going to add some logic to it for the center and the radius of it. So that the center of this sphere will be moving in a shape and the particles will be spawning in random positions. Now, for that, let's get started by um, time node and multiply it, and go to settings in here and change the second one to vector 3 and multiply it by a vector 3, and x will be 3, this will be 4, and this will be 5. Remember that I'm doing exactly the same things that Unity did in their example, and these numbers are exactly the same. And after that, we want to give it some waviness in x and y and z. So for the x, I'll be using a sine wave, and for the y, I'll be using a cosine wave. Now we can do two things here. You can take the z and use a sign for it, and then use a negate node to make it negative, or you can delete them and use x for it and negate the x for the z. Unity did this one. However, you can go with whatever you want. So I will just stick to this one also. So now let's create a vector tree here. Expand this and take the x to x, y to y, and z to x, z. Now, if I take this to the center and I'll go back to Unity, now you can see the particles are being spawned in the sphere, and the sphere is moving in the shape like this. Now, if I go back, we will be adding some randomness to the radius. So let's just take this a bit down. Yeah, that's a good value. And I will be connecting the time node to a Parallel noise, one dimensional. And if I take this to radius right now, and if you set this to 1, you won't be getting any change in the radius. It will always be the same. So for this, values higher than 1 will be giving you more details, and values less than 1 will be giving you less details. And the value of 1 won't be giving you any details, right? And Unity set this to 12. However, if I set it to very high values, you will get a lot of randomness that eventually it doesn't give a good cool effect for it. Now, in here, I changed this to 0.03 and 0.2. And now if I go back, you can see different thicknesses in our shape. That's because the radius of the position sphere has been changing, and this creates this. And if I increase this to a value of like 100, and go back to here, you can see a lot of randomness, and this is not giving a good result at all. So let's just get back to 12. Now, leave the update particle for now, and let's go for the output lit particle quad. Also, let's add some other things in here. Let's set the size will be 0.2, and also set text index. Yeah, let's leave that for later. Let's come to here and pay attention to this part, because if you miss something, you won't be getting the normal maps or thickness maps, and this will cause some problems with the effects later. So with selecting this lit quad block, come to here and change the material type to translucent and use a diffusion profile here. Unity has provided some default diffusion profiles, so you don't have to worry about where to get them. you have them instantly when you create a HDRP project. So I'll be choosing SSS01 and I'll check multiply thickness with alpha, change this to none and then to alpha, and use normal map and come down to here. You can see the UV mode here, and this UV mode is exactly the same thing as here. And change this to flipbook because we'll be using a flipbook, and here are our textures, you can see them. And after that, let's turn on cast shadows, use alpha clipping and generate motion vector. This is somehow optional. If you want to use blur effects, you have to enable this, and if you don't want, you don't have to enable them. Now let's get back to here and design our textures to the base color map and the normal map to the normal map, and change the blend mode to opaque, and flipbook size will be 4 by 2, and the alpha threshold will be 0.25, and the smoothness will be 0.196. And here you can see that the thickness has been replaced by the metallic, and here just change the normal scale to a high value, to the max value, and that will be 2. Now let's get back, and you can see the particles have been changed and they're giving us this effect. Now it's time to, let me see, yeah, actually let's add the last one that I set here, and that will be set text index random uniform. Yeah, that's what we want. And this will be from 0 to 8, because we have a flip book of size 8. This is 4, this is 2, and multiply it, we get 8. And now let's add the force in here and change the mode from absolute to relative and increase the drag to 3, right? And leave it for now, and let's get back to the scene view, and you can see the particles are moving, and you will be seeing these gaps. That's because you are seeing them straight and they have 0 rotation, and that is causing these gaps to be seen. So let's get back to the lead quad and add orient along velocity, and as soon as we get back to the unity, you can see that the particles are facing the direction that they are moving, and we do not see those gaps anymore. However, sometimes these things happen because they are moving in that direction. However, we can't do anything about them. Okay everyone, I realized that the video I recorded was a bit long, 2.6 minutes. I decided to split the video in 2 parts so you can follow along easier. And in the next video, we are going to add the actual logic for the force to get this effect, and this is called the curl noise, that is used to simulate fluids and volumetrics, and this will be a little complicated, so I'll see you in the next video.